Now it's the second lecture from industry. Now it's Vitaly Shiryaev from Novolipetsk Steel Company, Novolipetsky Metallurgический комбинат, for one who speaks Russian. So they're also the sponsors of our school. So yeah, thanks a lot for sponsoring us. Yeah, I'll pass the word to you.
Hello, my name is Vitaly. I'm from NLMK. NLMK is Novolipetsk Steel Company. We make steel, a lot of steel. It's #1 in Russia. So we have a lot of tasks, and some of them are related to artificial intelligence. Maybe a part of it, it's about focus of some properties and elements of machine learning, and I want you to introduce some of our tasks. Task #1, CHP. CHP is combined heat and power, a natural gas consumption minimization. We can think about this task as about ecology, not only about money. Well, energy consumption is, okay. I can't read this, but I remember. Well, industry is on the top. So industry is a large consumer of energy, total energy in the world. And iron and steel is on the top of industry. So iron and steel consumes a huge amount of energy. So we should take this into account and try to minimize this. Well, if we will take a closer look to this picture, we will see that we have that industry consumed 29%. And in metallurgy, the biggest part is sure it's a coal because of the process, blast furnace. And the second place is gas and electricity. So I'm not sure about every, but I think most of metallurgical company has its own CHP inside its facility, because we have a very cheap CO, carbon monoxide source, we have for free due to metallurgical process. What is blast furnace? Blast furnace looks like this. We have a coke coming from the top and ore, or iron ore. Iron ore, руда железная. I will translate some terms because I know that you can know English, but terms are very specific for this subject. Well, so this building, this device is very huge. It's 30 meters of height, so it produces a lot of CO. CO is a source of power if we will oxidize it to carbon dioxide. So it is useful to oxidize it and have a free energy and generate electrical energy by itself, because to buy electric energy is not cheap. We also have another source of carbon monoxide from coke ovens. It is also a part of technological process, and we have a natural gas from natural resources, from natural sources. Well, and then we put this to the boiler and produce steam and then produce electricity the common way. Well, combined heat and power, just to remind, I know that everybody knows how it works. We use something that can be burned. For instance, it could be carbon monoxide. Burning, heat the water, produce steam to the turbine to the generator, and here we have electricity. Okay. it looks like this. You see the human is small, and this building, it's a boiler where we can burn gas. Well, everything in metallurgy is huge. When you are first time on the plant, it's very interesting feeling. Well, you see a heat changing pipes and so on. Well, it's about metal, it's not about artificial intelligence yet. Okay, how we can formulate our task? We have a number of boilers, and its properties are not the same. That's why we can change a balance and optimize it, because if it could be the same boilers, we could do nothing. So we have a different boilers, and we need to understand where we should produce more steam or less steam, and how to balance gas, natural gas. Well, we have constraints, sure, a number of constraints like gas volume or coke factory gas input. We need a stream output to be constant, because turbine don't like when you change steam output. Individual constraints for every boiler, and other factors like we need steam pressure to be this or that. Unstable gas calorific capacities, because blast furnace works in a very unstable manner, so your gas properties unstable too, and so on. We have a lot of constraints. Well, sure, we should start from the simplest model. It's linear model. Well, if it is not enough, then we can use a piecewise linear model, and then if it's not enough, we should think what to do. Well, for this time, we have a linear model. What is this model about? This is about steam production as a function of gas consumption. So we have a different boilers. We have three types of gas: CO from blast furnace, CO from ovens, coke ovens, and also natural gas. We have this. And these coefficients may vary in time, because the process is not too stable. Well, we have a linear model, and how we will verify that this model is good for us? Here, the machine learning, part of artificial intelligence. Well, we have some historical data, and we need to build linear model. So it's a regression task. It's simple, but it's useful. How can we check that a linear model is enough? Well, okay, crosses is a real data, and circles is a model data. And we can check from historical data that our model is good enough. It's not perfect, but it is good enough, especially if we will remember that our data is very noisy, or that process is unstable. So we decided that linear model is enough. Here we have a machine learning part. Also, how we can verify this model? We can compare fact and model. This is a natural gas consumption from the historical point of view, and then we model this process using our model, and we see that it's good enough. It's about 5–10% of accuracy, so it's good. Well, so let's start to use this model. How can we write the optimization problem? Well, optimization is on every step of on any machine learning approach. So we have optimization task 2. We need to minimize the consumption of natural gas, but we have some restrictions. We need to produce steam. We need to produce enough value of steam, and some more restrictions and constraints. So we have a linear function. For 3 gases, for 13 boilers, we have 13 boilers. You see this is just a sum of boilers. And we need to use some chemistry to write chemical reactions to understand the volume of smoke. Because you cannot produce too much smoke, you have constraints due to chimney, to smoke pipe. Well, it's just a classical optimization task with linear function and linear constraints. It is well known that it could be solved very fast if it is not huge in terms of variables and constraints. This task is not huge. We can solve this on personal computer. If it could be a contest, we should stop here. But life is hard, life is more complicated, and we have more detail. So we have some special steps in this facility. We have a reduction cooling unit, for instance. Well, why do I talking about this? Just to remind that sport is not life, because I repeat, if it could be a competition, we should stop here. We could give you this task, you will decide this, and everybody glad. Well, it's just a proof of concept in real life. Then you should continue to this step. Hard life. We have a reduction cooling unit which can convert high pressure steam into medium pressure steam. Then you need to choose where do you want to produce your steam if you want a medium pressure steam. On a medium pressure steam boilers or on a high pressure steam boilers, and then convert it to medium pressure steam boilers. Well, we have a lot of difficulties inside this part. I will not read all this because it's boring. Well, the system, recommendation system, looks like this. If you're an operator of all these boilers, you have this interface which recommends you what to do. You don't need to think. You don't need to learn too much. You just start this application, and it will collect all data it needs, do some calculations from optimization point of view, and recommends you what to do, how to create the right balance. That's all. Operator can sleep and sometimes wake up and take a look and check. You can see. We cannot show all values. Sorry. For instance, here you can see that blast furnace gas is not optimal for this moment. You see yellow. Yellow means not too optimal. Green means optimal. So we have 13 boilers. Some of them are completely optimal, and some of them are not completely optimal. Also, red color are possible. It's completely unoptimal. And we see that deviations are just 1% or 8%. So it's very simple. Just add some gas or remove some gas. Here we are. Problems, as usual in real life, you do not have an ideal data. You need to do something with errors. Some parameters are not measured at all, not measured for particular units. For instance, we don't know about caloricity of gas, because its caloricity not stable too. So we need to do some approach, takes average values and so on. No information about some special device position some errors. We do not know fuel gas consumption and so on. So, well, it's real life. It's not just a sport, not a contest. So, if it could be a contest, the task could be solved, I think, for 1 week. In real life, we spend more than a year for this. So, it is good to have intelligence to solve these problems, not artificial, natural intelligence. Okay, task 2, rolling process optimization. You know the subject because our contest about rolling, you know. What is rolling? Rolling is this, this process. When you have a hot metal and then you roll it and you have a thinner metal. That's all. You're just producing thinner metal from thick metal using rollers. Rollers are not very stable too. It should be replaced every 3 hours. So we have a campaign for approximately 3 hours, and campaign looks like this. This is a strip width, and this is a strips from which you create the coils. Coils looks like this. So you have to start from narrow, then go further, and have this profile for campaign. How can you create this campaign? This is a very difficult mathematical task, frankly speaking. Now it is performed by human based on his natural intelligence. We're hoping that we can use artificial intelligence in this process too. That's why we gave this task to you. How can we understand that this is all campaign? Can we add one more stripe or not? Can we add one more coil or not? It depends on properties of roll properties. Every roll could be created from different materials. You see some possible metal for roll. We see that hardness can be different, tensile strength can be different, and so on. And price can be different, sure. So it's not always optimal to use very expensive rolls. Maybe sometimes for some kind of materials you want to roll, it's better to use the cheaper rolls. So it's an optimization task again. What our model of roll should consider? Well, we should take into account roll type, its steel type, its hardness, and its diameter and price. Coil type, you see chemical composition, width and thickness, surface quality. Because when a roll is not new, you have some lack of quality on the surface, and some products should be done with a very perfect surface. Some maybe not. And also you have a campaign schedule, roll types and temperature. Then you can build a roll wear prediction of wearing of this roll. So prediction is a part of typical artificial intelligence field too. Well, good prediction is very important. And then if you have this prediction, you can create an optimization task and optimize work of hot or cold mill. Cold mill is стан, прокатный стан. Well, this is about our competition. I think this information will be useful for those who takes part in this. We cannot tell you too much because we're afraid to do a competition unfair. So let's go to the task 3. Annealing heat profile optimization. What is annealing? Annealing это отжиг. It's a process when you put something into oven for a long time, for 1 hour or for 10 hours, or maybe for 100 hours. And then this process has a special thermal profile, like this. You can see, just an example. It could last for 5 hours and also can last for 5 days. It depends. Well, this is the oven. This is huge too, as everything in metallurgy. Human looks like this. And so it's about 10 meters of height. Well, you put coils inside this oven, and you use this heating profile, and then you have a changing in its inner structure. Well, you know that coils looks like grainy. Coils, metal inside contains grains. So when you're heating or cooling, you have you change its grain structure. Grain structure means properties. Metal could be soft, could be hard. Even if you have the same chemical properties, you can have different grain properties, and you will have different physical properties. So annealing is very, very important. So the question is, what is the right annealing process? And what is machine learning or something? Why do I tell you about this? Let me show how the temperature profile inside the coil looks like. I have a special video for you. What is it? It is a coil. If we will cut it, you can imagine that this is a eggs of this coil. It's a cylinder with a hole inside, and so it's a radial symmetry inside, almost in most cases. And how can we heat this coil? We heat this by radiation, infrared radiation. So the external part heats faster, inner parts heats slower. We have a hole inside, so a lot of radiation, a small part of radiation comes to this, so we have a heating profile. So it's hotter in these parts, and inside the coil it's a colder part. And sure, you know that grain structure depends on temperature profile, and we see the temperature profile definitely not the same for every point. So we need to optimize this profile to have a stability in its properties and so on. Well, it looks like, it's just a toy example. Why it is important? Why is it difficult? Because it is not just a piece of metal. It is coil. It consists of about 1,000 of layers. Each layers are not flat. It is thinner on the edge, and it thicker on the edge, thinner on the edge and thick at the center. So you have a larger thermal conductivity in the center because pressure is higher, and lower pressure conductivity on the edge. Also, it's a layered structure, so you have a thermal anisotropy. You have a high thermal conductivity in this direction and lower conductivity in this direction. So it's a meta structure. It's not just a piece of metal. Also some chemical reactions inside and so on. So it is very difficult to calculate properly. So I can tell you that we collaborate with institutes who helped us to calculate this in the right way. Well, you can see that we have another optimization task. How to create a right thermal profile to do things good. What is good? Okay, let's imagine that good is uniform heat profile in every point, for instance, just for instance. Where is an artificial intelligence? It's just a physics. You know about, I'm sure you know about, well, this picture of heating. You saw that. Surrogate model. Surrogate model is a part of artificial intelligence world. What is a surrogate model? Surrogate model, we can call it smart interpolation. When you put something, you know about the physical properties of your structure, and then you add some knowledge into this model, and it will create a good interpolation from physical point of view based on a few points. So you need to create a set of points. Each point takes hours or maybe days to calculate because the task is very complicated. Now you know why. Because you need to take into account all this physical stuff. And if you cannot create millions of points, but for instance, you need to find the minimum of this function. And then you need to create some special surrogate model or proxy model that can help you to do this, to optimize your process. This is exactly what artificial intelligence is. So it's difficult, but you can try. So we are trying to create these models too, so you can help us with this problem. That's all for now. I just want to remind you about our contest, about rolling task. The last day is July 14. We thought it could be tomorrow, but we decided to do it July 14, final submission. So you're welcome. Go to the Kaggle. You have links. Take a part. Try to win. Have a fun. That's all. Any questions? Welcome.
Any questions to the speakers so far? Okay, and I just want to make another. Will there be any more questions?
These problems have been resolved somewhere else. The steel industry exists for centuries.
Which problem exactly? All of this?
Yes, all of this.
Well, this problem is very. It's not a common problem, I think. Because we have this data and we do not have this data. Different plant will have that data and will not have that data. So task is not the same. As for proxy modeling, yes, it's very famous. And modeling of annealing it's old problem, yeah. But you know that industry do not like to share its results. Yeah, that's why maybe we should reinvent the bicycle. I don't know. But we should. Sure, we're trying to do a paper search, but not too much information about this.
One more question there. What kind of methods do you use to build this Poirot's model?
This mirrors, it's partial differential equations, like thermal conductivity equations, tensile equations, because it's a meta structure. So it's layered. Every layer has its own tensile. If you know, this part is hotter, then you grow, your perimeter is growing, and then tensile reducing, and so on. It's very complicated structure. So we have thermal, dynamic, tensile equations, a bit of chemistry inside because we have a hydrogenium here which passes through this structure, and so on. A lot of approaches.
You were saying about the ground truth model, but yes,
Okay, I see. We're just at the beginning. Just at the beginning. It's very complicated subject.
okay. Any other questions?
I invite you to help us.
First of all, let's thank the speaker again. Okay guys, so now we're going for lunch, and just a quick note that after lunch we have some workshops in this building, in the Digit building. It's all in the program, and just to remind that